Ever wondered how wall ties are placed or whether the DPC cuts through the cavity insulation? What about how the layers are fixed together? In this video, we'll answer those questions and more using a real student markup to explore DPMs, DPCs, wall ties, and how it all comes together in a foundation detail. So stay tuned until the end to learn more and get a free student pack including the complete PDF detail, a glossary of all the important key terms, and a quick set of notes to support your learning. Hello and welcome to the Detail Clinic. If you're new here, we're First in Architecture, an online learning platform dedicated to providing architects and students with resources, tutorials, and inspiration to succeed. With 6 detailing books published and a library of over 600 construction details, it's fair to say we spend a lot of time thinking about how buildings go together. This series is an opportunity to share that knowledge with you. Each video explores the intention behind a construction detail, clears up common points of confusion, and highlights the key principles that you can apply to your own projects. Today we're looking at a masonry cavity wall foundation junction with a ground-bearing slab with insulation below the slab. By the end you'll understand how moisture is managed at ground level, how the thermal line is kept continuous at the slab edge, how wall ties actually work, and how the components relate to each other so the detail performs as intended. First, let's run through some of the common elements we will see in this detail. DPC, which stands for damp-proof course. This is positioned in the external wall. It is a waterproof barrier installed horizontally within the wall to prevent ground moisture rising up through the masonry by capillary action. DPM, which stands for damp-proof membrane, is a physical waterproof barrier preventing moisture from entering the building floors and walls. Typically, this is a plastic sheet of some kind. Wall tie. This is a metal bar or strap used as a connector between the inner and outer leaves of the wall. The wall ties provide stability and prevent structural failure. The formed drip sheds any water that lands on the tie towards the outer leaf. There are many different types of wall ties depending on the structure. Perimeter upstand. This is the vertical insulation at the edge of the floor slab, which helps to reduce thermal bridging. Parge coat. This is a thin, airtight coat of mortar to the inner leaf that reduces air leakage, acting as the airtight layer. The insulated plasterboard is the internal lining that adds thermal performance and forms the final finish. Let's walk through the detail. Starting at the very bottom, the DPM on blinding is your first moisture barrier. It's only effective if it connects at the perimeter, so you'll see the turned up DPM lapping with the DPC line in the inner leaf. How the membranes are placed and lapped depends on the ground, construction, and other site constraints like presence of radon. The rigid insulation below the slab is continuous and tight to the edges. A separating layer or slip layer helps control the moisture movement within the floor build-up and allows differential movement without scuffing the insulation. The in-situ concrete slab provides a strong, level base to build non-load-bearing walls and floors off. At the edge, the perimeter insulation upstand is important. Without it, you would risk thermal bridge at the floor-to-wall junction. It runs the full depth of the floor slab and is a minimum of 25 mm thick. Across the cavity, which in this detail is 100 mm wide, fully filled with insulation, the wall ties stitch the two leaves together. The small kink or drip in the tie is deliberate. It breaks the path of any water or condensation running along the tie and ensures it sheds to the outer leaf. The cavity must extend a minimum of 225 mm below the DPC to comply with the Building Regs Part C, and the insulation in the cavity must extend a minimum of 215 mm below the floor insulation to comply with Part L of the Building Regs. In this detail, the insulation below the DPC line is moisture resistant in case of water ingress. Cavity thickness and insulation type and thickness are designed based on the Project U-value requirements, exposure zone, and other factors. The outer-facing brickwork protects against the weather. The DPC within this leaf blocks rising moisture and aligns with the turned-up DPM so the moisture line is continuous. Finally, the parge coat to the inner leaf tightens up air tightness, and the insulated plasterboard brings the internal lining up to the project's thermal target. So let's answer the exact questions raised on the student sheet so nothing's left hanging. How are the wall ties placed? The wall ties are set out in a staggered pattern as the wall rises, with the drip centred in the cavity. Spacing follows the project specification and exposure category. The key principle is that the ties connect the leaves without creating moisture bridges inwards. Part A of the building regs, which is called structure, provides the spacing requirements for wall ties for cavity walls. So horizontal spacing should be a maximum of 900 mil and vertical spacing should be a maximum of 450 mil. This image by the LABC demonstrates this really well. Next question. Does the DPM go through the cavity insulation? No. The DPM stays within the floor build-up and turns up at the perimeter to meet the DPC in the wall. It doesn't cut through or interrupt the wall insulation. The performance comes from the clean DPM-DPC connection, not from threading a membrane through the cavity. You might see cavity trays in some details that do go through the whole cavity, but we'll chat more about that for a future video. Next question. Are the layers drilled or mechanically fixed together? No, in this detail the system relies on lapped or taped membranes, abutting insulation and ties bedded in the mortar, not on drilling components together. Mechanical fixings are only used where specified, and then it's more about compatible tapes, closures, fixings that don't puncture the critical barriers. So let's go through the key points for this detail. Continuity is really important. Moisture barriers like DPMs and DPCs and thermal layers must read as continuous lines. Keep the DPC clear of finished ground level, which is usually 150 mil. Maintain the required clearance so rain splashback and bridging don't defeat the DPC. Mind the cavity. Keep it clear of mortar droppings. The ties should not become pathways for moisture inwards. Show the intent on your drawings. A small arrow or note at the perimeter lap, a clear upstand hatch, a few well-placed labels prevent most site queries. Project specifics matter. Substrate, moisture, exposure, finishes, acoustic and fire requirements, warranties, insurer requirements, and manufacturer guidance can all shift the final arrangement. There is always more than one way to design a detail. Download the accompanying student pack that includes the finished detail, glossary of terms, wash checklist for this detail and other key points. The link for your free download is in the description. Thank you so much for watching. We hope you found this useful. Please like and subscribe and all that good stuff. Happy detailing.